So, hello, maayong adlaw sa tanan kung asa man gali mo karon. I'm hoping and praying that you're all safe amidst of all the kanang tragedy na nasinati sa atong probinsya, no? Since bagyo man ta sini. In line with that, that's why I have decided na to create na lang videos for the sample problems sa ato ang 3 topics that we've discussed last time. So, please watch this video from the first part until to the last part in preparation for our upcoming exam. Sige. So, first problem. We have a cylindrical wooden buoy of height 3 meters and mass 80 kg which floats vertically in water. If its specific gravity is 0.8, how much will it be depressed when a body of mass 10 kilograms is placed on its upper surface? So, what is a buoy? Buoy is katuto siyang mag-float gani sa dagat na lain-lain siya shape. Sometimes it's cone, sometimes kay cylindrical, then lain-lain siya color. Most of the time na akong makita na buoy is color yellow, nga naka-cone. Ang purpose niya, at first when I was a kid, kay doon man migdagat, so always na ko siyang makita. I find it kinda like mushing trash, kay dako kay siya, din naglutaw lang ba. I didn't know its purpose yet. However, later on na nakalearn ko na that buoy is used for navigation sa mga people na mag-sail. It serves as a landmark to know if that area is for a kanang reserve nga for protection gani na type of ocean, kay daghang marine life nga place. So landmark siya kumbaga. So what we have here is a cylindrical wooden buoy. If we're going to illustrate it now, munya to ang dagat dayon, since cylindrical siya, then nag-float. Naa siya'y height nga 3 meters. Then, mass niya is 80 kilograms. If its specific gravity is 0.8, so natay SG na 0.8, how much will it be depressed when a body of mass 10 kg is placed on its upper surface? So, after ani, giadan to siya og 10 kilograms. So, lower na ay depression. 10 kilograms plus 18 eh. So, ang gipangutana ani, how much will it be depressed? Meaning, the difference of the change sa height nga nagsink. So, this will be our first point. Then, this is our second point. Katong 80 kg pa siya. Then, ikaduwa nga, katong 90 kg na siya. So, how will we solve it? If we already, if involved na taog height ani nga time, ato ang bulungon is ang volume. Kaya nga naman, what is the volume of our cylinder? The volume of the cylinder is area of the circle, area ani nga circle, times the height. So, ingana ang volume. Therefore, itong bulungon is the change of volume submerge. Kani. Then, volume nga na-submerge na siya. Then, through that, we could find the change of height. Sige. So, ang first natong bulungon. Ang ato ng bulungon is ang volume total sa ato ang material. So, since we were going to find sa volume total, di mangita sa tag density. So, to find the density, since it wasn't being given in the problem, the density itself, so we will find it through the specific gravity. So the specific gravity of the wood is 0.8. Remember that the formula of the specific gravity is the density of the wood, WD na lang, times the density of the water. Ay, divided by the density of the water, na SG. So, para makuha na to ng density sa wood, atong i-multiply si density of water times ni SG. So, therefore, density of wood is equal to 0.8, which is katong SG, times the density of the water, which is 1,000 kilogram per meter cube. So, ang atong makuha dire is 800 kilogram per meter cube. So, since na tayo density, then we could already find the volume total using so, di ba ang formula sa density is mass divided by the volume. So, sa mass, 80 kg, then may gipangita, i-equate na to siya sa density nga 800 kilogram per meter cube. Therefore, the volume total VT, o VT man is equal to 0.1 meter cube. So, nanatay first na volume na makuha. So, ato sa ning isa aside, the next we would find the volume sa katong na-submerge siya at 80 kg. Then, atong bulungon ang volume na na-submerge niya pagka 90 kg. So, stay put sa niha, yung VT. Next, ato ang bulungon si okay. So, karon we were going to equate the FB, buoyancy force, to the weight of our buoy. Malibog na ang buoy na noon. So, nganong gi-equal man? Always remember that once our material floats calmly, kanang stay put na gud siya nga nag float, meaning ana, our buoyancy force is equal sa iyahang weight. How about, ma'am, if mas lesser si weight compared ni buoyancy force? So, once that our buoyancy, ang ato ang weight is much greater than the buoyancy force, meaning musink ang ato ang material. If mas bugat atong material compared sa buoyancy force, that's the time na musing siya. However, if it's much greater, if the buoyancy force is much greater than the weight of the material itself, it would try to go up. Makita mo na nato na try siya go up. A very good example here is when we're going to use a bottle cup. Kanang empty nga bottle cup ganito na to ang i-close siradaan para dili mo sulod ang water. So, plastic bottle na lang, bottle cup. So, sa plastic bottle, let's say nga nisan lang tagdagat, ang plastic bottle, ato ang try to submerge siya sa ilalom sa tubig. Dayon, at a certain depth, we tried to let it go. Sa may mahitabo, the bottle cup would try to go up as much as it can. Then, once na mupop na siya sa water surface, calmly float na siya. So, kana siya nga act, kay ang ato ang paglagay na to sa tong hand, we try to add a force and weight sa ato ang bottle cup. However, as we let it go, ang na-remain na lang is katong weight mismo sa bottle cup, which is much lesser sa buoyancy force. Kay gi-equal man na to ato una. Na-equal man to siya ato una kay naman to force. Ito pag let go na siya, therefore, mas dako na tong buoyancy force compared sa weight sa bottle cup. Therefore, it would try to go up. Then, that act nga mag-try to go up, mauna na siya ang time or the scenery wherein the buoyancy force kay much greater than the weight itself. Then, pag once na makaato na siya sa water surface, then, float na siya calmly, it means that the buoyancy force already reached the equilibrium of the weight of the bottle. Oh. So, mauna ang time nga tawag dito, the buoyancy force will be much greater than the weight of our bottle cup. Sige. So, ato siyang equal. Kay it was being indicated sa problem na the mass of 80 kg floats. So, nag-float na siya, therefore equal. Dayon, if ato ang formula na to sa tawag dito, formula na to sa buoyancy force. Formula na to sa buoyancy force is specific weight of water times the volume displaced or the volume submerged. Ato na lang ilagay nga Vs at 1. Then, weight of the buoy. So, unsa man ang kaning specific weight of the water kay diba ni? Ma-dissect into density of water times gravity times the volume submerged is equal to WB. Nga naman nato siya ma-dissect. Ma-dissect siya kay, diba, ang formula sa specific weight is equal to weight divided by the volume. Then, if we're going to dissect na po, atong tungaon ato ang dig deep pa ang weight, its mass divided by the gravity, ay mass times gravity over volume. Then this mass over volume, this is density. That's why our specific weight is just density times gravity. Okay. So now, ma-equal ni siya. Then, if we're going to i-dissect na po ng ato ang weight, it's only mass times gravity. So, since both sides do have a gravity, so i-cancel out the gravity, dahil kanina lang ang mabilin. Density of the water times the volume submerged at 0.1 is equal to mass. So, ang density sa water, unsa ganito, we have 1,000 kg per meter cube. Vs at 1 is equal to mass na 80 kg. Therefore, Vs at 1 is equal to 0.08 meter cube. Kaya makancel man eh. So, nanatay V total, then nanatay volume submerged, katong iyang weight is 80 kg pa. So, next, atong kwaon is ang volume submerged nga katong 90 kg na. So, at VS2, nakuha naman to na to a while ago, no? Katong P, density of water, times volume submerged at 2 na din na 1 is equal to the mass. So, density of water is 1,000 kg per meter cube times Vs at 2 is equal to mass nga 90 kg. So, VSS2 is equal to 0.09 meter cube. So, nanatay VS1, VS2. Karon ang change na ang atong bulungon. So, the change of the volume is equal to VS2 minus VS1 is equal to 0.09 minus 0.08 is equal to 0.01 meter cube. So, nanatay change of the volume. So, now, remember that the formula of the volume of a cylinder is area times height. We weren't given a height, diba? We weren't given a height. We weren't given an area. Ang gihatag lang sa to is height. So, this is the time that we can use the volume total nga una na itong nakuha, which is katong 0.1, to find its area of the circle, because the area of the circle, of course, same buoy naman ang gigamit, therefore equal lang gihapon na sila, regardless if ang mass is regardless if ang mass is 80 kg or 90 kg. Sige, so ang nakuha na itong VT una is 0.1 meter cube. So, ang VT is, so, nibog na ko. So, 0.1 meter cube is equal to area of the circle times height. Then, ang height na ito nga gihatag is 3 meters. So, times 3 meters. Therefore, area of the circle is, pila man? 0.033. Then, since na natin area sa circle, then we could already get the height of the volume submerged using the change of the volume. So, since our change of the volume is 0.01 meter cube, di makuha na nato ang height. So, change of volume is equal to area of the circle times height, change of height. So, pila tong change of volume niya? 0.01 meter squared. 0.01 meter squared is equal to change sa circle kani 0.03 change of circle 0.033 dayon times change nga height. So h nga change therefore is 0.3 meters. Sige. So ing anaon ang ato ang pag-solve sa difference niya atong at point 1 then at point 2. So now we will proceed to problem number 2. We have here a vertical rectangular gate of 1.5 meters 1.5 meter wide and 3 meter high is submerged in water with its top edge 2 meters below the water surface. Find the total pressure acting on one side of the gate and its location from the bottom. So, in this problem, we were being asked of two answers. First is the total pressure acting on one side of the gate. The next, and its location from the bottom. So, unsa man ang iyang dere is in kilonewton. So, we weren't really being asked about sa pressure, but sa hydrostatic force. Nga naman, because unit analysis, ana siya dere nga dapat in kilonewton, then that unit is a unit of force. Di siya unit of pressure. Kaya diba, ang units of pressure dapat na ay, area sa ibaba. So, that's why, hydrostatic force ang ato ang pangitaon. So, una, na siya diri na atay rectangular gate. So, kanina naka-side view. Dayon, it's 2 meters below the water surface. So, if naka-front view, ang ato ang rectangular gate, kani is 2 meters. Then, kani 3 meters. Then, 1.5 meters ang iyahang width. So, nga naman nga na gate, diba, sa ilalim sa tubig. So, one of the applications here, nga nung nagka-gate ni siya, kay ka na mo kuanta og dams. Mo open man na, naman ay, para mo add og water, or mag-release sila og water sa dam is, na nasa light gate na isubmerge, then, it's either paana or paana ang opening, o basta, it's either both of the, how it opens. Pero ang gate nila nakasubmerged. That's why they will compute man pod ang hydrostatic force na ma-receive sa ato sa gate, for them to know as well if kayanon ba sa gate na mo-withstand with that type of force. So, now, unsay formula man sa hydrostatic force? I gave it sa notes. So, we have FH is equal to specific weight of the water times H bar times area. So, to those who were absent bitaw, ato last time before nagka-suspension, katong last discussion nako, please ask your classmates about the notes that I gave last time sa mga problems for you to catch up kay it might be very hard to follow if wala mo na nakuha na itong susugod kay na yung mga definition na ko atong wala na add sa notes. So, please ask your classmates regarding about it. So, going back, we have FH is equal to specific weight of water times H bar times A. So, kabalo naman tanong sa specific weight sa water. So, okay na to. H bar. How do we find the H bar? H bar is kanang gikan siya sa tunga sa atoang gate padulong sa water surface. So, since kabalo man tanga, ang iyang height is 3 meters, therefore, ang iyang tunga is 1.5. So, that 1.5 plus 2 meters, makuha na to si H bar nga 3.5 meters. Then, we have an area. Area is only 1.5 times 3. Okay na. So, makuha na to. Masolve na to si F. So, atong hydrostatic force is Y nga pila man ang specific weight of water sa pila man ang specific weight of water. So, if metric, naatay 9.81 kilonewton per meter cube times H bar, which is 3.5 meters, times area nga 1.5 times 3 meter squared. So, cancel this one. Kilonewton na lang ang matira. So, FH is equal to 154.5075 kilonewton. First answer. Then, we were being asked and its location from the bottom. So, sugod sa bottom, ang atong hydrostatic ang atong FH na aman diri, no? Masinati. Then, kani Y. So, mauni ang pangita from the bottom padulong sa ato ang hydrostatic force FH. So, unsa man ato ang gamiton ani? Atong gamiton is what could we minus man sa ato sa tunga para makuha ni. We could use the eccentricity. Ano naman, what is an eccentricity? Eccentricity is ako drawing ko na lang nakabalik, no. Mauni, no. Dayon naadiri atong CG center of gravity, then naadiri si CP. Dayon, since yung total pressure acting on one side of the gate, ang pinaka-dako nga maka-receive og pressure sa atoang gate kay malocate sa CP. So, we could say na naa sa CP ang atoang FH. So, the difference between the CG and the CP is the eccentricity. Then, CG is always half of the gate. Kani, 1.5. So, for us to find the Y, is we will only deduct 1.5 sa eccentricity. So, atong kaon is ang eccentricity. So, E is I CG over area times Y bar. So, si ICG, this is the moment of inertia. So, the moment of inertia sa circle is BH cube over 12 divided by the area, which is 1.5 times 3. Dayon, Y bar, nakuha man nato tong Y bar na, no, which is 3.5. So, then, unsa pa'y sunod datong buhaton? Ato ang input. So, si B nato is sa ganitong base kay 1.5, ang height na to kay 3 meters. So, after nga pag-input ani na to tanan, makuha na eccentricity, E is equal to 0.21428. Then, i-minus na to si 1.5 minus 0.21428 is equal to 1.285 meters. Therefore, ang location sa ato ang horizontal force is 1.285 meters. So, now we will proceed to number 3. We have here determine the size of a pipe which will deliver 8 liters per second of medicine oil with a viscosity of 6.10 times 10 to the power of negative 6 meters squared per seconds, assuming laminar flow conditions. So, saon man eh. Ang gibulong is ang sa pipe. We were already given Reynolds, since ang ni-mention man siya dali ay og laminar flow conditions, so we will involve, this involves Reynolds number. Ana man siya, assuming laminar flow condition. So, to those who were absent, ang laminar flow, this is the type of flow gani sa water nga katong ga-flow siya but it looks like mas siya gatikig o mas siya optical illusions, but as you kanang gatulo din imong iana, makita nato nga gatulo siya sadyang tikig ragid siya, meaning walay noise nga nasinati ang kana nga flow. Sige. So, assuming laminar flow condition, so atong i-assume that ang iyang Reynolds number RE, sige. Ato ang RE is automatic nga 2,000. Kay nihatag man kong ranges atong sa notes na kong gihatag, no. So, laminar flow, ang maximum niya is 2,000. So, atong ilagay is 2,000. Then, we have here, gihatag viscosity. Unit sa atong viscosity is meters squared per second. So, that unit, in that way, we can determine na type of viscosity niya is kinematic viscosity. Nga naman, kay ang kinematic viscosity, ang iyang unit is stoke. Then, 1 stoke is equal to 1 centimeter squared per second. Then, centimeter is the unit of length, same as 1 meter. We can convert the two, vice versa. So, this can as well be converted as stoke. Therefore, this is kinematic viscosity. So, we have kinematic viscosity of 6.10 times 10 meters squared per second. Dayon, unsay sunod? Deliver 8 liters of medicine, 8 liters per second of medicine, medium oil. Medium ba ni? Kana. So, unsa man na? Is it a volume? Naman siya time. So, if our volume, na sa iyang unit na ay time, seconds, hour, minutes, meaning it is a volume flow rate. Ang meaning sa volume flow rate, that is the quantity of volume being delivered in a certain amount of time. So, kana 8 liters per second. Therefore, Q is equal to Q ang symbol sa volume flow rate. Q is 8 liters per second. So, I'm hoping, no, nga naka-encounter na mo volume flow rate during your thermodynamics. Kaya naman na siya sa thermo. Pud as well, no, nga ma-encounter. Then, ang gipangita is determine the size of the pipe, meaning the diameter D. Sige, so, unsaon man ni. Since we were given natay kinematic viscosity, natay Reynolds number, atong gamiton is katong formula in getting Reynolds number using kinematic viscosity, which is RE is equal to VD over M. Ana. So, natay RE which is 2K, di ba? 2K. Dayon, naatay kinematic which is 6.10. Pero, wala tay velocity. Kaya kaning di mo man ang missing na gipangita. So, how would we get V? Since we were given tawag dito, a volume flow rate always remember that the formula of volume flow rate, Q, is equal to area times the velocity. So, since we are dealing with pipe, therefore, the area is circle. So, pi d squared over 4. So, kaning d is just the same sa d na ato ang gipangita. Dayon, v nga velocity. Dayon, kaning q, gihatag naman nato, no? Nga 8 liters per second. So, pwede rin nato ni siya ma-equate. So, v, therefore, is just 4q over pi d squared. Ano? Oh, q ni siya. So, gikan ni nga formula, gikan dire sa q times av. Sa pi d squared over 4 times v. So, gi-transpose. Therefore, makuha ning v is equal to 4q divided by pi d squared. So, kani, ato ning i-input sa atong main na formula. So, RE is equal to V. Since wala tayo V, atong gamiton is katong gikan sa volume flow rate. So, 4 Q over pi D squared times D divided by kinematic viscosity. So, D, cancel lang ni, kay same. So, napay isa nga D nga matira dire. Then, atong i-input, so 4 times Q nga 8 liters per second. So, that 8 liters, ato na siyang ilista na nato siya og meter cube. Since 4 times 8 liters per seconds as dayon liters is equal to 1 meter cube over 1,000 liter. Dayon, divided by pi d nga isa na lang, di na lang siya squared, i-cancel mo na to diri. So, kana nga d mo na itong ibulong over pi d over 6.10 times 10 to the power of negative 6 meter squared per second. Then, itong Reynolds number, kasi since it's laminar flow, i-equal na to siya 2,000. Therefore, ang matira is cancel ni. Dayon, napatay isa nga meter squared, kani cancel. So, naatay isa nga matira nga meter, kay meter squared, minus divided by meter cube. Therefore, ang D na to is equal to 0.835 meters or 835 mm. So, mauna ang final answer. Sige. So, that's all for our sample problems. Please practice more. Again, in preparation for our upcoming exam. So, thank you guys and amping tanan.